In today's class, let us learn how to solve problems related to average speed and average velocity of bodies in motion. We shall first make the concept of average speed and average velocity. Let's make it clear. First, let me talk about average speed. Average speed is defined as the total distance over total time taken for the journey. Simply remember, average speed of a body is the ratio of the total distance covered to the total time taken. For example, if a boy starts from the point A and travels to point B, and let's say he travels 5 kilometers distance in a time at a speed of 4 kilometers per hour, and from B to C, let's say that it is 6 kilometers distance, and now he walks at a speed of 5 kilometers per hour and stops his journey at the point C. So what is the total distance? Total distance in this case is 5 kilometers plus 6 kilometers. And what is the total time he has taken? Total time for the entire stretch of journey from A to B and B to C. From A to B, he is traveling a distance of 4 kilometers and at a speed of 4 kilometers per hour. So time is 5 by 4. Plus here he is traveling 6 kilometers at a speed of 5 kilometers per hour. So the time taken for the journey from B to C is distance over speed. That is 6 by 5. Therefore, you can simply say that the average speed in this case is 5 plus 6, 11 kilometers by 5 by 4 plus 6 by 5. You simplify, you get the answer. So remember, average speed can be found just by considering the ratio of total distance over total time. So that's the definition of average speed. Now come to the point number 2. If S1 and S2 are the distances traveled with velocities V1 and V2, then the average speed in this case is given by the formula S1 plus S2 over S1 by V1 plus S2 by V2. Now this is a special case. S1 is the distance travelled by a body and S2 is the distance travelled with velocity V1. S1 is travelled with velocity V1 and S2 is travelled with velocity V2. Then the average speed for the entire stretch of journey is S1 plus S2 divided by S1 over V1 plus S2 over V2. See, again, this is nothing but total distance. Total distance over S1 by V1 is nothing but T1. That is time to cover this part of journey. And the time to cover this part of journey is T2 plus S2 by V2 is T2. So you can also find the average average speed of a body by using the formula S1 plus S2 over S1 by V1 plus S2 by V2. If S1 and S2 are the distances travelled with velocities V1 and V2. Now supposing S1 is equal to S2, let us say a man walks from A to B and again he walks down from B to A again. This is S1, A to B is S1, B to A is S2, and clearly you see that S1 is equal to S2. If these two distances are equal, then how to find the average speed? In such a case, average speed is simply given by twice V1, V2 over V1 plus V2, where V1 is the velocity to cover a distance of S1 and V2 is the velocity to cover a distance of S2. You can just substitute here S1, S2. Let's say S1 is equal to S2 is equal to S. So in this case, this becomes, I am just substituting in this formula. So this implies if S1 is equal to S2, and let us call it as S, then I put S plus S over S over V, V1 plus S over V2. So it is 2S over V1, V2 is the LCM. Now this is SV2 plus SV1. Now you can take S common factor and cancel S and S, and this V1, V2 goes there, 2 times of V1, V2 over V1 plus V2. Simple calculation. You can do it. So remember, if S1 is equal to S2 and V1 is the velocity to cover a distance of S1 and V2 is the velocity to cover a distance of S2, and if S1 is equal to S2, in that case, the average velocity, average speed, not velocity, average speed is given by 2V1, V2 divided by V1 plus V2. Similarly, we have if S1, S2, S3 or the distances traveled by a body in successive time intervals, say T1, T2, T3, etc., then what is average speed? Total distance. The basic formula to find average speed is total distance over total time. Total distance is the sum of all these individual distances over total time, where T1, T2, T3 is the time of each interval. T1 is nothing but S1 by V1. Distance by speed is time. And that's about the average speed. So we talk about three fundamental formula. Fundamental basic formula number one is average speed is total distance by total time. And average speed is S1 plus S2 over S1 by V1 plus S2 by V2, and if S1 equals S2, then this formula reduces to 2 times of V1, V2 over V1 plus V2. And if many stretches of journeys of distances S1, S2, S3 have been completed successively in time intervals T1, T2 and T3, then average speed is S1 plus S2 plus S3 plus over T1 plus T2 plus T3 plus dash dash dash. Now let's also know something about the average velocity. Okay, that's all about average speed. Now this is average velocity. The average velocity of a particle is given by, in the first instance, it is given as V equals V1 plus V2 over 2. When, in this case, V stands for the average velocity. This is the average velocity. When a distance is covered in two equal intervals of time. Supposing this is the total distance. AB is the total distance. And this distance is covered in two equal intervals of time. Say supposing this is 1 hour, and to cover this distance also the body takes 1 hour. Here time is an important factor. It is covered in equal intervals of time. In such case, if V1 is the velocity for the journey for the first half, V2 is the velocity for the journey of the second equal interval of time, then the average velocity is V1 plus V2 over 2. A simple equation. And the average velocity V can also be written as V1 plus V2 plus etc. plus Vn over n, where V is the average velocity when a distance is covered in n number of equal intervals. Supposing, let's cover the distance between A to B in n number of equal intervals. This is 1n, second, third equal interval, fourth equal interval, fifth, etc. and this is the nth one. First, second, third, fourth, fifth, etc. and nth one. So the entire distance from A to B is divided, or it is covered in such a way that it is divided into n number of equal intervals. Then what is the average velocity in this case? V1 is the velocity of the first interval, V2 is the velocity of the second interval, and similarly Vn is the velocity for the last interval. Then V is equal to V1 plus V2 plus V3 plus etc. till the last interval, that is nth interval, divided by all number of intervals, n intervals. So here we come across two basic formulas for average velocities. This is if the body covers a distance with two equal intervals, then it is v1 plus v2 by 2, where v1 and v2 are the velocities in each of these intervals. If a body covers a particular stretch of distance in n number of equal intervals, with each interval having velocities v1, v2, v3, different velocities in equal intervals of time, then the average velocity is v1 plus v2 plus v3 over n. Now here we also have one more last basic formula, that is about n by v equals 1 over v1 plus 1 over v2 etc. 1 over vn, where the distance is covered in n equal parts with velocities v1, v2 and v3. Before coming to this, I would like to tell you about average velocity formula. V equals v1 v2 divided by v1 plus v2. So this particular formula is used to calculate the average velocity of a body when a distance is covered in two equal halves with velocities v1 and v2. Now this is the distance. Say supposing you want to travel 100 kilometers, from A to B is 100 kilometers. You divide, exactly this is 50 kilometers and this is 50 kilometers. Now you have traveled this first 50 kilometers with velocity v1, second 50 kilometers is with velocity v2. Here notice that it is not in equal interval of time, but is equal intervals of distance. Here time is not a criterion. Here the entire stretch of journey is divided into two equal halves, and each of these halves is covered with velocities v1 and v2. In that case, the average velocity of the body moving from A to B is v equals v1 times v2 over v1 plus v2. And this is with respect to two halves. Supposing there are n number of such parts, there are only two parts here. If you have n number of parts, 1, 2, 3, 4, 5, 6, 7 and n, the entire stretch of the distance between A to B is covered, is divided into n number of parts, and in each part the body has velocity v1, v2, v3 etc. and the last part its velocity is vn. Then the average velocity is given by n over v, where v represents the average velocity, n is the number of such parts, equals 1 by v1 plus 1 by v2 plus etc. to 1 by v3. So this is the formula for average velocity. So most important formulas: average speed, total distance over total time. Average velocity is v equals v1 plus v2 by 2, where the distance is covered in two equal intervals of time. To use this formula, time is a criterion. V equals v1 plus v2 plus etc. vn by n is an extended version of this. And if v equals v1 v2 by v, the average velocity v is given by v1 v2 over v1 plus c2, where v is the average velocity when the distance is covered in two equal halves with velocities v1 and v2, as explained in this case. And lastly, if the entire stretch of journey is divided into n such parts, and if each of these parts is covered with velocities v1, v2, v3, then the average velocity of the body is given by the formula n over v, where n represents or n indicates the number of such parts of the journey, v is the average velocity, n over v equals 1 over v1 plus 1 over v2 etc. to 1 over v3. So with this, now let's see how we can do problems on average speed and average velocity. Now problems are very important because you have problems coming from this concept even in the entrance exam. So let me just take a few of them. A man goes from his house to office, or house to market. Okay, it's given as market here. House to market with a uniform speed of 5 meters per second and returns with a speed of 2 meters per second and returns with a speed of 2 meters per second. What is his average speed? What is his average speed? What is his average speed? Full stop. Comment on his average velocity. Comment on his average velocity. Many people will get confused to arrive at the answer as while going he is going with a speed of 5 meters per second. While coming he is coming at a speed of 2 meters. So average speed is 5 plus 2 over 2. That is 7 over 2. That is equal to 3.5 meters per second. Now I said this formula is wrong because see, this V equals V1 plus V2 by 2 can be used only when the distance is covered in 2 equal intervals of time. That means how much time he takes to travel from house to market should be the same when he travels from market to house also. So the time must be same. Here he is moving at different speed. It's not same. Now then which of these formulas can be used to calculate his average speed? Say, man goes from his house, this is house, to market. Say this is market. With a uniform speed of 5 meters per second. And returns with a speed of 2 meters per second. So while returning from market to house, the speed is 2 meters per second. What is his average speed? Comment on his average velocity. Anyway, if you analyze this particular situation, the distance between house to market, that is S1, is same as the distance between market to house, S2. So we have a situation where S1 equals S2 equals S, let's say. Distance between house to market is same as the distance between market to house, let's keep the distance as S. So when S1 equals S2, we can simply use the formula for average speed is 2 times of V1 V2 over V1 plus V2. We have a ready-made formula here. I showed you how we arrive at this. If you substitute S1 equals S2, then you get this. So that is 2 times of his velocity V1 5 meters per second, velocity V2 2 meters per second over V1 plus V2 5 plus 2. That is 2 5s are 10 into 2 20 over 7 meters per second. So his average speed is 20 by 7. This is the answer. Okay. We'll have the next one. A bus travels with a speed of 40 kilometers per hour. 40 kilometers per hour in the first hour. In the first hour, come on, 50 kilometers per hour in the second hour, and 60 kilometers per hour and 60 kilometers per hour in the third hour. In the third hour. what is the average speed of the bus for the first 3 hours? What is the average speed of the bus for the first 3 hours? For the first 3 hours. Okay. Now I remember in the last problem there was one more last part of the problem, that is about comment on the average velocity. Okay, remember? Yeah, I just forgot to tell about that. In the previous problem, I'm just going back to the previous problem to tell you about the average velocity. As a person moves from house to market, and again he moves from market to house. So what is the net displacement? Net displacement in this case is 0, because he is coming back to his initial position. So there is no displacement undergone, or there is no displacement that the person has made, because he has come back to the initial point. So displacement is 0. So, and in fact average velocity is rate of change of displacement over time. Since 0 over time gives you 0, average velocity of the person is 0. So remember, in all such cases, when the particle comes back to its initial position of journey, it will not have average velocity, it will have only the average speed. Okay. In this problem, a bus travels with a speed of 40 kilometers per hour in the first hour and 50 kilometers in the second hour and 60 kilometers in the third hour. This is first hour, second and third. And they are all, the duration of each of these interval is same in terms of time, because first hour, second hour, next 60 minutes, third hour, next 60 minutes. So here it has covered 50, here it has covered first it has covered 40, here it has covered 50, and here it has covered 60. Now we can just use this formula. You want to find what? You want to find the average speed or average velocity of the bus, because in this case, whether it is average speed or average velocity do not have any difference, because the bus is heading from A to B. It is undergoing displacement. It is traveling from A to B. So you may even say it is having average speed from A to B, or it has average velocity from A to B. Both are same. Now since distances are covered in n equal intervals of time, here n is 3, first interval, second interval, third interval, and v is the average velocity. So simple, v equals v1, that is 40, plus v2, that is 50, v3, that is 60, all divided by 3. So 60 plus 50, 110, 110 plus 40, 150 by 3, that is just 50 kilometers per hour. That's all. You can straight away make use of the formula that you know to encounter any particular situation on an average speed or average velocity. Okay. Next problem. A car covers the first half of the distance. The first half of the distance between two places. Between two places at a speed of 40 kilometers per hour. 40 kilometers per hour. And second half and second half at 60 kilometers per hour. Calculate the average speed of the car. Calculate the average speed. The average speed of the car. Calculate the average speed of the car. Now I have to just think of the situation. Which of these formula will match to solve this problem? A car covers the first half of the distance between two places at a speed of 40 kilometers per hour and second half. So here the entire distance is divided into two equal halves in terms of their distances, not in terms of their time. If it is in terms of time, this is the formula. If this is in terms of distance, this is what the formula. So the entire stretch of the distance is divided into two equal halves. That is, this is S1 and this is S2. Or in this case, S1 is equal to S2 equals S. And the first part of the journey is covered with a speed of 40 kilometers per hour. And the second is covered with 60 kilometers. So V1 equals 40 and V2 equals 60. S1 equals S2 equals S. Now it's very simple. You know, average velocity is 2 times of V1 V2 over V1 plus V2. It is 2 times of 40 into 60 divided by 100. 60 plus 40. So this gives 6 4s are 24, 24 2s are 48 kilometers per hour. That's the average speed of the car. Okay. Okay, we'll have the next problem. A car is moving along a straight line. A car is moving along a straight line. Say OP. Say it's moving along a straight line. Say OP. OP is the straight path of the car. In the figure given below. Okay. It moves from O to P in 80 seconds. It moves from P to O. It moves from P to, it moves from O to P. It moves from O to P. It moves from O to P in 18 seconds and returns from P to Q and returns from P to Q in 6 seconds. In 6 seconds. In 6 seconds. What are the average velocity? What are the average speed? What are the average velocity as well as speed? Okay, what are the average velocity and average speed of the car in going A from O to P, B from O to P and back to Q. Anyway, a diagram to illustrate the description of the journey of the car is also given. So diagram is like this. The car is moving first in the positive direction of the x-axis. So this is the starting point. This is 60. This is 120, 180, 240, and 240 is marked as point Q. Then you have 300, and this is 360. This is point P. 360 is point P. 420 and so on. Okay, let's see what you want to find now. What do you want to find? The car is moving along a straight line, OP. It moves from O to P in 18 seconds. It moves from O to P. O to P, it takes 18 seconds. In moving from O to P, it takes 18 seconds and also covers by covering 360 meters. Okay. And returns from P to Q. And returns from P to Q in 6 seconds. The time to travel from P to Q is 6 seconds, covering. You know what is the distance from P to Q? 360 minus of 240. That is 120 meters. Okay. So this is the situation. So here 360 meters is the distance and 18 seconds is the time. And here 120 meters is the distance and 6 seconds is the time. Now if you want to find the average velocity and average speed from O to P. Now let me just first tell you about average velocity. Average velocity from O to P. You know, average velocity from O to P. O to P is, the motion O to P is happening with a definite sense of direction from O to P, so it is displacement. And you know that velocity is displacement over time. So 20 meters per second is the average velocity. And average speed is also 20 meters per second. Because when the particle moves from O to P, you may even say it is average speed or average velocity. Because O to P is a motion with a definite sense of direction. Now if you now talk about from O to P it is over, from O to P, and this is O to, I think it should be O to Q. Make the correction. From O to Q. What is the average velocity when the body travels from O to Q? You see, from O to Q, average velocity is displacement over time. What is the time that the particle takes to travel from P to Q? The total time is 18 seconds from here to here. See, from here to here it is 18 seconds. From O to P it is 18 seconds. And from P to Q it is 6 seconds. So you take off this 6 seconds. So 18 minus 6 is 12. So if the particle has to travel from O to Q, then the time it takes is 12. So again it is 20 meters per second. And lastly, back to Q, from O to Q and back to Q. O to Q and back to Q. I'll just check the problem once again. Okay. Yes. From O to Q I gave, and back to Q and back to Q. So now you have now talked about this one. So average velocity. I'll talk about average speed now. Is from O to P it is 360 plus P to Q is again 120 and divided by 18 plus 6, because from here to here it is 18 seconds and this is 6 seconds. So simplified, we get the answer. So this is 480 divided by 24. It is 20 meters per second. Okay? We will understand this type of problem by taking one more example. Let me just give that example to you. I think this will make our idea more clear. A man starts from his house. At A at 7 a.m. Come on. Walks with a uniform speed. Walks with a uniform speed. Walks with a uniform speed along the straight path AB. Along the straight path AB. Along the straight path AB and reaches B at 10 a.m. Full stop. At B, he turns and walks with a uniform speed. At B, he turns and walks with a uniform speed. Along the path BA. And reaches C at 10:20 and reaches C at 10:20 a.m. and continues to walk towards A and continues to walk towards A. If AB equals 12 kilometers, and BC equals 2 kilometers, find okay, I have to now just rub off this matter here, because a lot of things have to be found in this problem. So I write them one by one, covering all the aspects of motion. There are some questions. Okay. Find. I write here. A. What is the average speed for? A. What is the average speed for? Number one, journey from A to B. Number two, journey from B to C. Number three, journey from A to C. Number four, for the whole journey. Now, next item B. What is the at what time will he He will return to the starting point A. He will return to the starting point A. Then we have C, which asks what is his average velocity for? What is his average velocity for? Number 1, journey from A to B. Journey from A to B. 2, journey from B to C. Journey from B to C. 3, journey from A to C. Journey from A to C. Number 4, for the whole journey. For the whole journey. For the whole journey. Okay. See, in this problem, a couple of things related to the motion of the person is asked. Now, before doing this problem, let's read the problem once and understand what is it. A man starts from his house at A at 7 o'clock. So this is man's house. It is at A and now the time is 7 a.m. and walks with a uniform speed along the straight path AB, reaches B at 10 a.m. So this is B. And when he has come to B, it is 10 a.m. At B, he turns and walks with a uniform speed along path BA. So after reaching this point, he changes his mind and starts walking towards A and reaches the point C at 10:20. So here it is 10 o'clock, now he is coming back. Now here he reaches C. Now what is the time? 10:20 a.m. It's given that if AB equals 12 kilometers, so this stretch from A to B is 12 kilometers and B to C is 2 kilometers. B to C, this is 2 kilometers. Find out these questions, answer to these questions. Okay, first, let's talk about average speed. What is the average speed for the journey from A to B? First one, average speed. This is for the journey from A to B. You know, the basic formula for average speed is total distance from total time. What is the total distance from A to B? That is distance AB divided by time taken, T for AB. That is time required to travel from A to B. It is given that the total distance from A to B is 12 kilometers and man starts at 7 and reaches B at 10 o'clock, means he has taken 3 hours. So this is average speed is 4 kilometers per hour. So the man's average speed in moving from A to B is 4 kilometers per hour. Now what is his average speed from B to C? You want to find average speed from B to C. So this is distance BC divided by time BC. What is the distance B to C? 2 kilometers. Divided by how much time he has taken. Now at B it is 10 and now to arrive at C he comes at 10:20. So he takes 20 minutes. That is 20 minutes into 1 by 60, because 1 minute is 1 by 60th of an hour. 20 minutes is 20 by 60. 20 into 1 by 60. So 20 into 1 over 3. And that's 6 kilometers per hour. So remember, he has started walking from B to reach A at a speed of 6 kilometers per hour. Okay, so 2 things have been found. The next thing, the average speed from A to C. Average speed from A to C. Average speed A to C, that is distance A to C over time A to C. We know that the distance from A to C is 12 minus over. Now the time taken by the person to reach from C to this point A. Okay, so he has to walk down how many kilometers? He has to walk down another 10 kilometers because he has already covered 2 kilometers till he reaches the point C, and from C to A he has to walk 10 kilometers. He has to walk 10 kilometers and he is walking at a speed of 6 kilometers per hour. So obviously how much time he takes? He has to walk down a distance of 10 kilometers and he is walking at a speed of 6. So distance by speed gives time. So this is 10 over 10 by 6, that is 5 by 3. Okay, we can just calculate that. Please calculate. So how much you get? Yeah. 6 kilometers per hour. In the third problem, the third case is to find the average speed for the journey from A to C. Yes. See, you have been asked to find the average speed, not velocity. I did it for actually velocity. See this, average speed from A to C. Now speed is the total distance covered. So he has to travel from A to B, that is 12, and again back to C, 2, that is 12 plus 2. And to travel from A to B has taken 3 hours, plus to travel from B to C has taken 20 minutes. 20 minutes into 1 by 60th of an hour. That is 14 divided by 3 plus 1 by 3. Okay. When you simplify, you get the answer. That's 14 over 3 into 1 by 3. It is 14 over n by 3. Yeah. Simplifying this, you get 21 by 5 kilometers per hour. So that's the answer. A to C. Now what is the average speed for the whole of the journey? For the entire journey. For the entire journey. For the whole. No, for the whole of the journey. Average speed for whole journey. See, whole journey comprises of distance A to B and back B to A, that is 12 plus 12. A to B, he takes 3 hours. And B to C is how many hours? B to C is from here to here he has taken 20 minutes, and from C to A how much? We already calculated 2 hours. So 48 by 5 kilometers per hour. That's the average speed. At what time he will return to the starting point A? At what time he will return to the starting point? See, he took 3 hours from A to B, and at the rate of 6 kilometers per hour, he started walking down, and he walked down the entire stretch, and While going he took 3 hours, while coming he took 2 hours. So 3 plus 2 totally it is 5 hours. So here he left at 7 o'clock, he reached here at 10 o'clock, 3 hours, and you add another 2 hours for return journey. So he will come back to A at 10:12 a.m. p.m. So he comes back to the position A at 12 p.m. 3 hours while going, 2 hours to come down. So 5 hours from 7 o'clock, that is 12 o'clock in the afternoon. And what is his average velocity for A to B? A to B, the same as the average speed, what we calculated. What is his average velocity from B to C? B to C, we had C here. The same as whatever the value of the average speed for B to C. For the whole journey, what is his average velocity? For the whole journey, the person goes from A to B and comes back to A. So net displacement is 0. Net displacement is 0. I told you whenever there is displacement 0, there is no question of average velocity. So for the whole of this journey, the value of the average velocity is 0. Okay? Fine. Now let's have some more problems. Okay. The next problem is like this. The motion of two objects. The motion of two objects, A and B, are shown in figure. Which body possesses greater velocity? Possesses greater velocity. Full stop. What is the ratio of their velocities? What is the ratio of their velocities? Now let's first write out the graph given, the figure given. This is the velocity graph of figure object A and object B. And object A makes 30 degree with x-axis, object B is making 60 degree with x-axis. Okay. You know that the slope of the position time graph represents the value of the velocity. So whichever the one which has got more value for the slope, that body possesses greater velocity. Here, the slope of line OA is tan 30, and tan 30 is 1 by root 3, and slope of the line OB is tan 60, and tan 60 is root 3. So you know that root 3 is greater than 1 by root 3. So that body B, therefore the body B possesses greater velocity. And the second part of the problem, it says, what is the ratio of their velocity? A ratio of their velocities can be written like this. Ratio of their velocities is VB over VA, it is tan 60 over tan 30, That is root 3 by 1 by root 3. You can simplify this further. Yes, that gives you 3. Correct. In simplification, you get 3 as the answer. Okay, we will take up more problems in the next class. But to summarize what all we have learned, I would like to just remind you that average velocity, the difference between average velocity and average speed. While calculating the average speed, we take the total distance by total time. Average speed is total distance by total time. It's given by S1 plus S2 divided by S1 V1 plus S2 V2, where V1 and V2 are the velocities of the body during when it describes the distance S1 and S2. And if S1 becomes equal to S2, then average velocity is 2 times of V1 V2 divided by average speed is 2 times of V1 V2 divided by V1 plus V2. So these two are the most important formula that you should keep in your mind to do the problems. Anyway, we will do more problems in the next class.